39019, Novi Single.
Mission control went silent when astronauts reported a winged aircraft outside the station, but the real shock came when they zoomed in. During a standard observation cycle aboard the International Space Station, astronauts noticed a strange object drifting along Earth's outer edge, a shape that looked shockingly similar to a passenger jet, far above any altitude a plane could ever reach. At first, it seemed like a camera illusion or a reflection, but once the crew zoomed in, the details revealed something far more mysterious, raising questions about debris, classified technology, and the limits of what we think can reach space. Stay with me, because the closer we examine this object, the more the story shifts from a simple sighting to a mystery that challenges everything we assume about aircraft, space travel, and what really orbits above us. So, follow along as we break it all down. The orbiting laboratory. The International Space Station circles Earth at a remarkable altitude of roughly 250 miles above the surface. This massive structure, which took over 10 years to build and involved collaboration between 14 different countries, serves as humanity's most ambitious orbital laboratory. The station measures 356 feet from end to end, making it about the size of a football field, including the end zones. Every single day, astronauts aboard this engineering marvel experience something that ground-based humans can only dream about. They witness 16 sunrises and 16 sunsets as the station completes its orbit. The ISS travels at an astonishing speed of 17,500 miles per hour. To put this in perspective, a typical commercial airplane cruises at around 600 miles per hour, which means the space station moves roughly 29 times faster than the planes flying below it. This incredible velocity allows the station to complete a full orbit around Earth in just 90 minutes. During this time, astronauts pass over 90% of Earth's population, giving them unprecedented views of cities, oceans, mountains, and yes, even airplanes flying far below them. Living aboard the ISS comes with unique challenges and extraordinary opportunities. The crew members float in microgravity, conducting scientific experiments that cannot be performed on Earth. They also spend considerable time photographing our planet, documenting everything from weather patterns to natural disasters. Among their countless observations, one particular achievement stands out: capturing images of commercial aircraft from space, something that requires perfect timing, specialized equipment, and exceptional skill, the perfect shot. On July 19, 2015, a member of Expedition 44 achieved something remarkable. While orbiting high above Great Exuma Island in the Bahamas, this astronaut managed to photograph a commercial airplane, complete with its distinctive contrails streaking through the atmosphere below. The image captured not just the plane itself, but the white condensation trails it left behind, creating a stunning visual record of aviation against the backdrop of turquoise waters and fractured cays. This photograph, later released by NASA, would fascinate people around the world and demonstrate the incredible observational capabilities available from the space station. The technical challenges of capturing such an image are absolutely staggering. Consider the difficulty. The space station is moving at 17,500 miles per hour, while the airplane below travels at roughly 600 miles per hour in a completely different direction. The distance between them measures approximately 250 miles, yet the astronaut needed to identify the tiny aircraft, track its movement, and snap the photograph at precisely the right moment. The crew member used a Nikon D4 camera equipped with an impressive 1150mm lens to achieve this feat. In the weightless environment of space, astronauts can actually take steady shots without needing a tripod, as there is no gravity to cause camera shake. What makes this achievement even more impressive is that contrails, the white streaks left by airplanes, are much easier to spot than the aircraft themselves. These condensation trails form when hot exhaust from jet engines meets the cold air of the upper atmosphere, causing water vapor to freeze into ice crystals. From space, these contrails can stretch for miles, creating visible lines across the Earth's surface. The photograph from 2015 showed both the airplane and its dual contrails perfectly framed against the ocean channels weaving between the Bahamas Islands. Seeing Earth from above, when astronauts first arrive at the International Space Station, they often describe feeling overwhelmed by the view. From their unique vantage point 250 miles above the surface, they can see the curvature of Earth, the thin blue line of our atmosphere, and the vast darkness of space beyond the station's large windows, particularly the famous cupola module, provide panoramic views that have inspired countless photographs and videos. Astronauts spend their limited free time gazing at Earth, trying to capture its beauty and share it with people back home. The view from space reveals details that might surprise you. While popular myths suggest that astronauts can see the Great Wall of China or the Egyptian pyramids, the reality is quite different. Astronaut Neil Armstrong debunked these myths after his Apollo 11 mission, explaining that, from the Moon, he could only make out continents and large geographical features. Even from the closer vantage point of the ISS, human-made structures prove difficult to spot without magnification. The Great Wall blends in with the surrounding terrain due to similar coloring, making it nearly invisible even through a camera lens. However, certain features on Earth stand out brilliantly from space city lights at night, create spectacular displays, with major metropolitan areas glowing like jewels against the dark landscape. Astronauts have photographed fascinating patterns in urban lighting, from the mercury vapor lights of older city districts glowing blue-green to the newer sodium vapor lights creating orange glows. They have captured lightning strikes, auroras dancing across the poles, and weather systems swirling across oceans. Among all these observations, spotting airplanes presents a unique challenge that combines technical skill with astronomical luck: the science of contrails. Understanding why airplane contrails are visible from space requires diving into atmospheric science. When a jet engine burns fuel, it produces hot exhaust containing water vapor, carbon dioxide, and other gases. As this exhaust emerges into the frigid temperatures of the upper atmosphere, typically between 30,000 and 40,000 feet altitude, the water vapor rapidly freezes into tiny ice crystals. These crystals form around microscopic particles in the exhaust, creating the white streaks we recognize as contrails. The process happens almost instantaneously. The persistence of contrails depends entirely on atmospheric conditions. In dry air, contrails dissipate within minutes as the ice crystals evaporate. However, when the atmosphere contains sufficient moisture, contrails can last for hours or even days. Over time, these persistent contrails spread and evolve, eventually transforming into artificial cirrus clouds, indistinguishable from natural cloud formations. Scientists studying climate have discovered that these human-made cirrus clouds now cover a significant portion of Earth's atmosphere, particularly over heavily traveled air routes. From the perspective of astronauts aboard the ISS, contrails serve as bright white markers against the blue of oceans or the varied colors of land. In a photograph taken in May 2019, an Expedition 59 crew member captured a contrail over the North Atlantic Ocean as the station approached Ireland, showing the distinctive trail stretching across the water far below. These images provide valuable scientific data about air traffic patterns and atmospheric conditions. They also demonstrate the remarkable visual acuity possible from orbit, where even relatively small features on Earth's surface become observable under the right circumstances. The equipment and technique. Astronaut photography aboard the International Space Station represents a fascinating blend of art and science. The station stocks several high-quality cameras, primarily Nikon DSLRs, along with an impressive array of lenses ranging from wide-angle to extreme telephoto. For capturing distant objects like airplanes, crew members rely on powerful lenses, sometimes reaching 1150 mm or even longer focal lengths. These specialized lenses can magnify distant subjects significantly, making it possible to photograph objects that would otherwise appear as mere specks. The weightless environment of space actually provides advantages for photography. Without gravity pulling on the camera and photographer, there is no need for tripods or other stabilization equipment. Astronauts can brace themselves against the station's walls or windows and hold even heavy camera lens combinations perfectly steady. However, this advantage comes with trade-offs. The station itself vibrates slightly from various mechanical systems, and astronauts must time their shots carefully to minimize any motion blur. Additionally, photographing through the station's windows introduces challenges, as the thick glass can distort images or create reflections. Veteran space photographer Don Pettit has spent more than 160 days aboard the ISS across multiple missions, capturing some of the most iconic images from orbit. He has explained that successful photography from space requires extensive planning. Astronauts use specialized software that predicts when the station will pass over specific locations on Earth, accounting for lighting conditions and cloud cover. They catalog targets in advance, waiting sometimes for months to get the perfect combination of orbital path, daylight, and clear weather. The spontaneous capture of an airplane contrail represents a rare moment where preparation meets opportunity. The challenge of distance. The sheer distance between the International Space Station and commercial aircraft creates extraordinary difficulties for observation. While the ISS orbits at approximately 250 miles altitude, commercial airplanes typically cruise between 6 and 8 miles above sea level. This means roughly 242 to 244 miles of separation exists between astronauts and the planes they might spot below. To visualize this distance, imagine trying to see a small object from 242 miles away on Earth's surface. The task seems impossible, and in most cases it would be. However, several factors make airplane detection possible from space. The human eye, under ideal conditions, can distinguish objects much smaller than you might expect, especially when those objects contrast sharply with their background. An airplane's white contrails stand out brilliantly against the blue of the ocean or the varied textures of land. The contrails themselves can stretch for tens of miles, creating long, thin lines that are easier to spot than the aircraft generating them. Additionally, the unique perspective from space, looking straight down rather than across a landscape, reduces atmospheric interference and improves visibility. Astronaut David Saint-Jacques addressed this topic directly when a student asked if he could see planes from the ISS. He explained that while spotting individual aircraft proves extremely challenging, observing contrails happens regularly. During certain times of day, particularly morning hours over heavily trafficked regions like Europe and North America, astronauts can see numerous contrails crisscrossing the landscape below. These white lines create patterns reminiscent of abstract art, revealing the invisible highways of international air travel. The density of these contrails over certain regions provides a striking visual representation of human activity and global connectivity. Famous captures from orbit. The 2015 photograph of a plane over the Bahamas represents just one example of astronauts capturing aviation from space throughout the ISS's operational history. Crew members have documented numerous instances of airplanes and their contrails. In May 2002, astronauts photographed contrails over the Rhône Valley west of Lyon, France, showing how these condensation trails begin as thin lines before spreading to form cirrus clouds. The image revealed multiple aircraft tracks crisscrossing the landscape, illustrating the high volume of air traffic over Western Europe. Another memorable capture occurred in May 2019, when an Expedition 59 crew member photographed a single contrail stretching across the North Atlantic Ocean as the station approached Ireland's coast. The image, taken from 255 miles above Earth, showed the stark white trail standing out against the deep blue of the ocean waters. NASA enhanced this photograph to improve contrast, making the contrail even more visible. These images serve multiple purposes. They inspire public interest in space exploration, provide scientific data about atmospheric conditions, and demonstrate the capabilities of human observers in orbit. Astronaut Scott Kelly, who spent nearly a year aboard the ISS from 2015 to 2016, shared many photographs during his mission, including the Bahamas airplane image that captured worldwide attention. His documentation of life aboard the station and views of Earth below helped people understand what astronauts experience daily. The photographs of airplanes and contrails particularly resonated with viewers because they connected space exploration with everyday experiences. Everyone has seen airplanes in the sky, but seeing them from space provides an entirely new perspective on human flight and our technological achievements. The reverse view. While astronauts occasionally spot airplanes from space, people on Earth regularly observe the International Space Station passing overhead. This reverse observation proves much easier due to the station's enormous size and highly reflective solar panels. The ISS measures 356 feet across, and its acre of solar panels catches sunlight brilliantly, making it the third brightest object in the night sky after the sun and moon. Under optimal conditions, the station can outshine even the brightest stars and planets visible from Earth. NASA operates a service called Spot the Station, providing notifications to people worldwide about upcoming ISS passes over their locations. The station looks like a bright, fast-moving star that glides silently across the sky without the flashing lights characteristic of airplanes. It moves noticeably faster than aircraft, covering the distance from horizon to horizon in just a few minutes. The best viewing times occur shortly after sunset or before sunrise, when the observer stands in Earth's shadow, but the station still catches direct sunlight. During these windows, the ISS appears as a brilliant white dot smoothly traversing the heavens. Many people mistake the ISS for a UFO during their first sighting because of its unusual appearance and swift, steady motion. Unlike airplanes that have flashing navigation lights and sometimes appear to change direction, the space station moves in a perfectly straight line across the sky, maintaining constant brightness until it enters Earth's shadow and vanishes. This predictable behavior makes it easy to identify once you know what to look for. The symmetry of observation is beautiful. Just as astronauts look down and occasionally spot our airplanes, we look up and regularly see their home in space. Planning the perfect shot, capturing meaningful photographs from the International Space Station, requires meticulous planning and preparation. Astronauts cannot simply point a camera at Earth and hope for the best. The station completes an orbit every 90 minutes, and during each orbit, it passes over different regions of the planet. Its orbital path, inclined at 51.6 degrees relative to the equator, means the station regularly flies over populated areas between these northern and southern latitudes, but never directly over the poles or extreme northern and southern regions. To photograph specific locations or events, astronauts use sophisticated software that predicts the station's future positions relative to Earth's surface. This navigation software shows where darkness and daylight fall, provides cloud cover forecasts, and displays upcoming orbital paths. Astronauts can input desired targets, such as specific cities, geological features, or weather events, and the software calculates when the station will pass overhead with favorable lighting conditions. This planning process often begins months before a mission, with astronauts compiling lists of targets they hope to photograph during their stay. French astronaut Thomas Pesquet, known for his stunning Earth photography, has explained that timing everything correctly presents the biggest challenge. Even when the station's orbit carries it over a desired location, that pass might occur during nighttime, rendering most features invisible except for city lights. Cloud cover further complicates matters, often obscuring targets completely. Astronauts sometimes wait weeks or months for the perfect combination of daylight, clear weather, and orbital alignment to photograph their planned subjects. The spontaneous capture of an airplane contrail therefore represents a special kind of achievement, requiring both preparation and the ability to recognize and respond to unexpected opportunities. What astronauts can and cannot see. The limits of human vision from orbit fascinate both scientists and the public. Many people assume astronauts can see far more detail than actually possible with the naked eye. While the station orbits relatively close to Earth compared to satellites in higher orbits, 250 miles still represents a substantial distance. The human eye's resolution, combined with atmospheric effects and the vast distance involved, restricts what astronauts can observe without optical assistance. With the naked eye alone, astronauts can distinguish large geographical features, major cities, and obvious contrasts like coastlines, rivers, and mountain ranges. At night, cities appear as glowing clusters of light, with the brightest metropolitan areas visible even through some cloud cover. Las Vegas stands out particularly brilliantly, with the strip's lights so intense that astronauts report seeing it easily without any magnification. During the day, color contrasts help identify features: dark rivers cutting through lighter terrain, green forests against brown deserts, and the white of clouds or snow against virtually any background. However, individual buildings, cars, or people remain invisible without powerful optical equipment. Even with cameras and telephoto lenses, photographing individual structures proves difficult unless they have distinctive shapes or colors. Airports, for instance, might be identifiable by their long runways, but individual aircraft parked at terminals would appear as indistinguishable specks if visible at all. This reality makes the successful photography of airplanes in flight all the more impressive. The combination of the plane's contrails, the contrast against water or land, the powerful camera lens, and the astronaut's skill all had to align perfectly to create those remarkable images. The broader impact. Photographs of airplanes taken from the International Space Station carry significance beyond their immediate visual appeal. These images remind us of the remarkable technological progress humanity has achieved in the past century. 100 years ago, powered flight itself was a novelty, with the Wright brothers' first flight occurring in 1903. Today, we have people living permanently in space, orbiting Earth, while photographing other people flying between continents far below. This layering of achievements represents extraordinary progress in a remarkably short time span. The images also provide scientific value for researchers studying atmospheric conditions and aviation patterns. Contrails and the artificial cirrus clouds they create have measurable effects on Earth's climate. Scientists estimate that contrail-induced cirrus cloud cover over the United States increases by roughly 1% per decade, affecting how much heat Earth radiates into space. By documenting contrail formations from orbit, astronauts contribute data that helps scientists understand these climate impacts. The photographs serve as visual records of air traffic density over different regions, potentially useful for studying global transportation patterns and their environmental consequences. Furthermore, these images inspire public interest in both aviation and space exploration. When people see photographs of airplanes taken from space, they gain a new perspective on the scale of human achievement. The connection between everyday experiences like commercial air travel and the extraordinary environment of the International Space Station makes space seem more accessible and relevant to regular people. NASA's decision to share these images publicly helps fulfill the space agency's educational mission, showing taxpayers the value of their investment in space exploration while encouraging young people to pursue careers in science, technology, engineering, and mathematics. From 250 miles above Earth, astronauts aboard the International Space Station have accomplished something remarkable by capturing photographs of commercial airplanes and their contrails. These images showcase the incredible observational capabilities available from orbit, the skill and dedication of astronauts who document our planet, and the fascinating connection between different modes of human flight. The next time you see an airplane passing overhead, remember that somewhere above that aircraft, astronauts might be looking down, perhaps with a camera ready to capture another stunning image of aviation as seen from space. What other everyday objects do you think astronauts might be able to photograph from the ISS? Share your thoughts in the comments below.